Hello and welcome to section 9.1. This is the first video for chapter 9, and yes, we are jumping to chapter 9 from chapter 5 like I explained earlier this week. Because we were talking about triangles for such a long time, it just kind of makes sense to continue talking about triangles instead of weirdly jumping back to them at the end of the semester. So we are jumping to chapter 9 and we're kind of popping around in chapter 9. We're not going to do everything. But we do want to just touch on a few things here. So we're going to be talking about right triangles specifically, and then we'll do a little bit of an intro into trigonometry. Section 9.1 is what we're going to do today in this video. We're going to talk about the Pythagorean theorem, which some of you might already know, and we're going to talk about its converse and how we can apply it to different triangle problems. So just to reiterate, objectives, Pythagorean theorem and converse. Okay, so this is Pythag, and yes, you will hear me say Pythag. I don't like to say the Pythagorean theorem. I'm going to say Pythag. So what it is if I have triangle ABC, if I know it's a right triangle, so I have a right angle over there, then I can square each leg. So I have two legs. One leg is called A, one leg is called B. My hypotenuse is always going to be C, always, always, always. A squared plus B squared, or leg squared plus leg squared, is going to equal C squared, or your hypotenuse. So this right here, this is the Pythagorean theorem. Like I said, some of you might already know this. If you don't, make sure that you're writing this down. This is going to be the big thing for today and kind of for the next couple of days. This is going to keep coming back. This is one of those formulas, kind of like slope, midpoint, distance. It's going to keep coming back. So make sure we know this one. Hypotenuse is always your longest leg. And like I said, it's always going to be C. In this case, we do need to specify between legs and the hypotenuse. All right, so before we get into different problems, we need to talk about Pythagorean triples. So a Pythagorean triple is a set of positive integers. So what do I mean by integer? Do we remember what integers are? So integers would be any kind of whole number, basically. And here I specifically want positive ones. So an integer could be 2. It could be 17, some kind of whole number. So I'm going to have a set of positive integers. Let's call them A, B, and C. And they're going to have to satisfy, so they're going to work in Pythag, in A squared plus B squared equals C squared. So notice from this equation that C must always be the greatest number. So there again, C represents our hypotenuse. When I'm dealing with Pythagorean triples, we're just talking about sets of 3 numbers, but really they could and do represent the 3 sides of a right triangle. So an example would be the set of numbers 3, 4, 5. And let me just prove to you that these numbers do satisfy Pythag. 3 squared plus 4 squared, we're going to check, does it equal 5 squared? So 3 squared is 9, 4 squared is 16. I know that 5 squared is 25. Does this work out? 9 plus 16, that equals 25. Cool, I'm getting something that makes sense. So I've just kind of proven to you that 3, 4, 5, they are a Pythagorean triple because they satisfy that equation. A squared plus B squared equals C squared. So take a second. Can you think of any other Pythagorean triples out there? So another example would be 5, 12, 13. And I don't want you to take my word for it. I want you to plug these in. Do these work? So your greatest number is 13, so that one would go by itself. So check, plug this into your calculator. Is 5 squared plus 12 squared, does that equal, I'm going to put a little question mark there. I want you to check it. Does it equal 13 squared? Another example would be 8, 15, and 17. Another example would be 7, 24, 25. There are tons of different groupings here of different Pythagorean triples. And the cool thing is that these all work with multiples of triples. So I'll go back to 3, 4, 5 for a second. What if I multiplied each of those numbers by 2? I would get 6, 8, 10. 6, 8, 10 is a multiple of my 3, 4, 5 triple. And 6, 8, 10 also works. It also satisfies. So 6 squared plus 8 squared equals 10 squared. You're going to find out that that does work. I get 36 plus 64 equaling to 100. And you can just double check. 36 plus 64 does equal 100. So that does work out for us. So once again, Pythagorean triple, any set of 3 numbers that work in the Pythagorean theorem. So let's get into some triangle problems here. We're going to start with this one. So they want us to find the length of the hypotenuse. So our hypotenuse here is going to be this AB side over here. And then check to see that the side lengths form a Pythagorean triple and then explain why. So 20 and 21, those are my legs. And A and B in my Pythagorean triple, they're kind of interchangeable. So it doesn't really matter which one you assign for A or B, as long as you know, okay, those are my legs. Those are going to go together on the one side of my equation. So I'm going to get 20 squared plus 21 squared equals my hypotenuse squared, that C value, that missing piece. Use your calculator here, but 20 squared is 400. 21 squared, we're going to get 441. That's going to equal C squared. Over here, add these up. 841 equals C squared, and then I want to figure out what just C is. So the square root of 841 would give me 29. So C is going to equal 29, and that does work out to a nice whole number, a nice integer. So here we're just going to double check 20, 21, 29. They do work as a Pythagorean triple. I can say that this set is a Pythag triple because they satisfy Pythag. So because 20 squared plus 21 squared equals 29 squared. All right, let's try another one. So example 2, find the value of x, so that's a missing side, and in this case, x is a leg. So we just need to be a little bit careful when we're plugging into Pythagorean theorem. Make sure your hypotenuse, your longest one, is always going in for c. So I'm going to use a squared plus b squared equals c squared. And I'm going to make sure that I'm plugging in x into either a or b. Like I said, it doesn't really matter which one, but make sure that 8 and x are your legs. So I'm going to just plug it in for a. So x squared plus 8 squared equals 20 squared. And then our answer is going to have to be in simplest radical form. So what that means is you're going to have a radical in your answer, but make sure that you're simplifying it as much as you possibly can. I don't want you to plug this into your calculator. I don't want a decimal for this one. Kind of think back to like circles. Remember how we would have exact or approximate? It's kind of what's going on here. Your simplest radical form, this would kind of count as your exact. If you plugged it in and got a decimal, that would kind of be your approximate, okay? So back to the problem. X squared, 8 squared is 64. 20 squared is 400. Let's keep solving it. Minus 64, I'm getting x squared equals 336. I just want to solve for x, so I'm going to take the square root. So x equals the square root of 336, and we have to now figure out, can I simplify that any further? So here's where I want to kind of pause for a second. You hopefully in a different math class learned how to simplify radicals. If you didn't, then we're going to have to, maybe look some methods up online and figure that out. I'm going to kind of remind you about the branch method. So that one is where you would break this up into factor pairs. I have my calculator here. I'm going to pull that out. Okay, let me see, is 336 divisible by 2? Okay, it is. So I'd break that into 2 and 168, and then I would say, okay, 168. Could I split that up? You could see if that's divisible by 2. Okay, it is. And you're going to keep kind of going down this branch method. So maybe that looks a little bit familiar. And then anytime you see a number show up twice, so here I see a 2 and a 2, okay, I know I could pull 1, 2 outside of the radical and keep going with this, right? So that's one method. That's kind of your branch method. I'm actually going to erase this because I want to show you a different method. Maybe you've heard of this one, maybe you haven't. I'm going to talk about this method that I call the perfect square method. So perfect squares, what I mean by those would be numbers like, okay, 2 squared equals 4. 4 would be an example of a perfect square. 3 squared equals 9. 9 would be another example of a perfect square. 4 squared equals 16. And you could go on and on, right? 25, 36, 49. These would all be examples of perfect squares. So the way I like to simplify radicals is checking, okay, 336, is that divisible by any perfect squares? And you want to find the largest, so I'll write this down here, find largest perfect square that your original number is divisible by. So 336, we could check, okay, is it divisible by 4? It is, but is it divisible by any larger perfect squares? Keep going down the line. Check 9, check 16. So I'll tell you for 336, it is divisible by 16, which means I can rewrite square root of 336 as square root of 16 times 21. Those are equivalent forms, okay? Anytime I have two numbers multiplied under a radical, I'm allowed to split those up. Totally legal. Now what I have is the square root of 16, which is just 4 times radical 21, and that is my simplest radical form. So like I said, I wanted us to take a second here. If you have a different method for simplifying radicals, use whatever method works. I do not care which method you use as long as it's going to work. So use whatever method works for you. If you like the branch method, do that. If a different teacher taught you a different method, use that, okay? If you need to look up other methods online, I'm going to kind of go with the assumption that we do have a basic understanding of how to simplify radicals. If you don't, email me. I can try to get you some other resources, or try this perfect square method, all right? So I know it might be a little different, but in my mind, this one is kind of a shortcut way. I think sometimes it can actually be a little easier than the branch method, or take less time once you get used to it. So once again, use whatever method. I'm just giving you my method. That's how I tend to like to simplify radicals. So our answer here would be x equals 4 square root 21. Once again, that's my simplest radical form. All right, on to the next one. So here's an example where I get to apply the Pythagorean theorem. So I have a 50-foot supporting wire right over here. It's attached to the 75-foot antenna. Okay, cool. It's attached 20 feet from the base, so it must be anchored exactly 20 feet from the base of the antenna. How high from the base of the antenna must the wire be attached? Give an exact answer, so think about your simplest radical form, and give a 1 decimal approximation. So simplest radical form, we love that in the math world, but sometimes in the real world, decimals are a little bit more useful. So we're going to go to the next slide, which will still have the diagram, and we're going to solve this. So in this case, I have this right triangle. I'll even redraw it over here too. I know this side is 50 feet. I know this side is 20 feet. I know it's a right triangle. They're asking me to solve for x. I don't actually care about the 75 feet, right? They're telling me that I have a 75-foot antenna. It's kind of extra information here. That's cool. That's awesome. But really what they're asking me to solve for is x. So that's what we're going to do. X is one of my legs, so that means I'm going to plug it in for either A or B. Let's plug it in for B this time. Once again, doesn't matter. You could have done x squared plus 20 squared as long as you know it's a leg and you're plugging it in for either A or B. 20 squared is going to, whoops, miss a square. 20 squared is going to give us 400 plus x squared. 50 squared is going to give us 2,500. Subtract the 400. I get x squared equals 2,100. Take the square root, take the square root. X equals square root 2,100. So at this point, I could simplify, and they want both our simplest radical form, our exact answer, and a decimal approximation. So I'm going to check what perfect squares is 2,100 divisible by. Well, it's divisible by 100. Right? So I could rewrite 2,100 as 100 times 21. I know the square root of 100 is just going to be 10. So my exact answer would be 10 times 21. And then officially it would be feet, right? Here's a real world problem. I need to include units. Or plug into a calculator would give us 45.8 feet. And that would be your approximate answer. All right, so use Pythag in the real world. I think you would actually be kind of surprised how much the Pythagorean theorem is useful. I like to tell the story about how my sister, who was an art major in college, she needed to use Pythag and trig to figure out how to hang one of her sculptures one time. So even art majors sometimes use the Pythagorean theorem in the real world. Alrighty, so your converse is saying if a squared plus b squared equals c squared, if that's true for a triangle, then you know you're dealing with a right triangle. Okay, so that is your converse. The Pythagorean theorem, you know that you're dealing with a right triangle, so you know a squared plus b squared equals c squared has to be true. The converse and two other theorems in this section are going to help us determine, just based on 3 sides of triangle, whether I'm dealing with a right triangle, acute triangle, or obtuse triangle. So that's our converse. So here's an example. Triangle has side lengths 85, 84, 13. Is it a right triangle? So remember, C always will have to be your largest. So 85 is going to represent C. And we're just going to plug in and see, does this thing work? So 13 squared plus 84 squared, those are my two smaller numbers. Do they equal, I'm just going to put a question mark there, do they equal 85 squared? So plug these into your calculators. 13 squared is going to give us 169. 84 squared is going to give us 7,056. Once again, I'm just going to leave the question mark. That's what I'm trying to determine. Do they equal each other? 85 squared is 7,225. When I add these two together, I do get 7,225, which equals the other side over there. So because a squared plus b squared equals c squared, this is a right triangle. And that would be your final answer. We are dealing with a right triangle because these numbers work in your Pythagorean theorem. All right, the last thing we need to chat about is these last two theorems. Like I said, these will help us determine if I'm dealing with an obtuse triangle, or an acute. So if c squared, that third side squared, that longest side squared, is greater than a squared plus b squared, you're dealing with an obtuse triangle. Take a second. I'll even erase these so you can just see the full thing. Take a second, write this down. If this is true over here, c squared is greater than a squared plus b squared, you're dealing with an obtuse triangle. Pause the video if you need to. Make sure that's somewhere in your notes. So on our previous theorem was if it equals, it's right. If c squared is greater than the side squared, it's obtuse. And then finally, if c squared is less than a squared plus b squared, your triangle is going to be acute. Okay, so like I said, pause, go back, write these down. Make sure you have these somewhere in your notes. These are going to be super important for us. And I've seen stuff like this pop up on SATs and ACTs too. Helpful things to know, all right? And keep in mind what you know about how sides and angles relate to each other, right? So for obtuse, you're dealing with something that's greater than 90 degrees. It does kind of make sense that c squared would be greater than a squared plus b squared, right? So try to process this a little bit intuitively as well. All right, we have one final example for the remainder of this video. A triangle has side lengths 6, 11, 14. Is it acute, obtuse, or right? So what we're going to do is we're going to plug these numbers in to a squared, b squared, and c squared, and we're going to see how do these two sides relate. Are they going to equal? Is one going to be greater than the other? What's going to go on here? And for this one, I'm going to write it with c squared on the left side, because that's how the theorems were set up. So just to make sure that we're comfortable with the less than greater than signs. So I'm going to just put a blank square here. That's what we're going to try to determine. Should an equals go in there, a greater than sign, or a less than sign? So which number should you plug in for C? Hopefully you said or thought 14. That's your greatest number. So I'm going to have 14 squared equals 6 squared plus 11 squared. 14 squared would give me 196. And we're going to see, okay, how does that relate to my other side with 36 plus 121? 196, how does that relate to 36 plus 21 is 157. So 196 is greater than 157. So c squared is greater than a squared plus b squared. What kind of triangle is this? Hopefully you're saying the answer or thinking the answer. Because c squared is greater, the triangle is obtuse. All right, and that is the end of our video. You will have a bit of homework to work on now. It's basically Pythag, and then if given 3 numbers, how do you determine is it acute, obtuse, or right? The converse and the last 2 theorems will help you out with that. All right, good luck on the homework. Email me if you have any questions.